The matrix of inferential statistics, this document right here, is basically what we're doing for the rest of the semester. So what do you have in here? Well, you have on the up and down side over there, the scale of measurement of the dependent variable, and your choices are, top row, nominal dV or counts, middle one is ordinal dV, and bottom one is interval or ratio dV. So why did we do 50 problems on scales of measurement and 100 problems on what's the IV and what's the dV? It's this. This is why. We need to be able to know those things so we can point out what is the dV and what scale of measurement is. So on the top here, we've got stuff about the IV. So we want to know, first of all, is there only one sample or one nominal variable? That's that first column. The next two are all about having two samples. You got two groups or two nominal variables, or if you want to compare. And then the last two columns are you've got three or more groups or three or more nominal variables. Yep. So why is there two columns for each of those? Well, we have something called the between groups IV or within groups IV. And we're going to talk a little bit more about that, but basically it's what's the research design? Is there different people in the levels of the independent variable, that is different people in the groups? That's a between design. Or is it the same people, they're matched people, they're related people? That's what we call a within design. So based on those things, the scalar measurement of the dV, scalar measurement, the number of levels of the IV, whether you've got a between or within design, that tells you what statistic you use for your dissertation or to answer a problem. Note that the bottom row on the far right is called parametric. These are the super fancy tests that most stats we do are parametric tests. These are the ones we are going to learn all of in the class, and just a smattering of the non-parametric ones. So this matrix of inferential statistics help you choose the correct inferential statistics test for analyzing study data. Choosing the correct inferential statistic for analysis depends primarily on three factors we just talked about. One, the dV scale of measurement / its nature, could be counts. Two, the number of levels of the independent variable. And three, the nature of the IV. Is it between groups or within groups? That is, what's the study design? So again, parametric tests or inferential statistics tests that are in that bottom row of the matrix. And these tests are special because they make assumptions about the populations from which the samples are drawn. Usually things like they're normally distributed, or you've got variances that are homogeneous, similar across the groups, things like that. Those are parameters that we are of the population from which they're drawn. That's what they call parametric tests, in case anyone cares. So note that for each parametric test, there is a non-parametric equivalent, sort of a backup or weed whacker test is what I call them, that you can be used as a backup in case the parametric statistical assumptions are strongly violated. So there's always a backup if you can't do the super fancy one that's sort of like not as great, but it works. So that's called your non-parametric equivalent. Those are the tests that are in the ordinal row directly above the parametric test. So you can figure it out pretty easy. Just look above the parametric test one row, and that is your non-parametric equivalent. So what is this whole betweens versus within groups research design thing? So in between groups designs, the persons who are in the IV levels or groups are different people. That's kind of how you know. If it's not that, then it's not a between groups design. Okay, so like they're all in your study, so that doesn't count that they're related. Okay, they all have some common characteristic of interest. That doesn't count, make them related. Like they're all fifth graders or whatever, psychologists. That doesn't make them related. It's like they're literally related. Okay, so if they're totally different people with no relationship at all, you've got between groups design. So within groups designs are the persons and the levels of the IVs or groups are related to each other in some way. So there's three different variations of within groups designs. Number one is what we call a repeated measures design. In these designs, it's the same people. It's literally the same exact people on all levels of the IV. Okay, so like before and after studies are repeated measures designs. You have the same people drinking Coke, Pepsi, and store brand soda and trying to taste the difference. you got a repeated measures design. If all people are tasting all three, repeated measures. Then you have, oh great, I love that it's one again. But anyway, it's number 2 is paired designs. So this is when the people in the IV or groups are literally related. So they're twins, they're romantic partners, they're spouses. And this is what we call a paired design. So there's not the exact same people, but they are related somehow, right? They're familially or by choice. So finally we get to 2, which should actually be 3. We have our match design. So it's different people, but they're matched. So you've created that relationship artificially. So the people in the IV groups or levels are matched on one or more important variables. So, we're going to match people on education into pairs and assign the 2 top educated people, one to one group, one to the other, next to one to one group, one to the other, etc. And we call that a match design. So if there isn't one of these 1, 1, 2, that is 1 to 3, you've got a between groups design. If they're not the same people, they're paired up because they're related, or you match them up artificially, it's a between groups design. So what are the 8 tests we will cover this semester? Number 1 is Pearson correlation. So that's when you've got 2 interval, ratio, or dichotomous nominal variables, and you just want to see if a linear relationship exists between them. So note that Pearson correlation is not in the matrix. It doesn't quite fit with the other ones, so it's just not in there, but that is one you learn, so it's one of the tests. There's something called the chi-square goodness of fit test, and this is when you've got a DV that counts only one sample / only one nominal IV. So you're just comparing across the counts of something. You want to know if they differ. Then we have a slightly more complicated chi-square. It's in a couple places in the matrix. It's called the chi-square test of independence. And again, the DV's counts. That's what makes it chi-square. If it's just counts of things, it's chi-square. Okay, you just got to figure out which one. And the way you do that is there are 2 or more samples or IVs, or is it just one? Okay, if there's 2 or more samples or IVs and you got a between groups design, it's this chi-square test of independence. If it's only one, it's a goodness of fit. So then we have the one we're doing this week, the one sample t-test. This is when you've got a DV that's interval or ratio, only one sample. Okay, only one sample. And you want to compare that sample to some real or hypothetical population mean. Okay, so one sample only, but the DV is interval or ratio, you got a one sample t. Continued, we've got independent samples t-test. So when you do this, this is when you got a DV that is interval or ratio. The IV's got 2 levels, and you got a between groups design. And we have the within groups equivalent of that. It's called the paired samples t-test. Same thing, except that you've got a within groups design. IV's interval or ratio, DV is interval or ratio. IV's got 2 levels. Within groups design, that's a paired samples t. And we have our super fancy ANOVA, which we talked about a little bit in regression, but now we're actually going to talk about it more in depth. What is it? Well, it's when you've got a DV that's interval or ratio, which basically puts you on the bottom row of the matrix, right? The IV has 3 or more groups, so it can be 3 to X, right? And you've got a between groups design. So DV's interval ratio, 3 or more groups between design, one way between subjects ANOVA, and there's a within groups equivalent of that. It's called one-way repeated measures ANOVA. Same thing, except you got a within groups design. DV's interval or ratio, IV's got 3 or more groups, and you've got a within groups design. So they're somehow matched or paired or whatever. So let's try this. So if you want to pause now and bust out a copy of the matrix, it wouldn't be a bad idea. But like print it from the slides. But we're actually going to go through some examples using the matrix to identify the proper test. So for each of the following study or analysis descriptions, identify the DV scale of measurement, the number of levels of the independent variable, and the nature of the independent variable. Is it between or within? Then, using the matrix and those 3 things, tell me what's the correct test. So number 1, a researcher compares IQ among social classes, lower, middle, upper. So IQ, how's that measured? Well, that's one of those psych measures, so that's going to be at least interval, right? We agree that all the psych measures we use in here are interval. So what's our independent variable? Well, it's your social class, right? And there's 3 levels, lower, middle, upper. So 3 level IV. So last question, interval or ratio DV, 3 or more levels of the IV. Do we have a between or within design? So the question answer that is are the same people going to be lower, middle, upper, or is it different people, right? Or I guess within would also be their match somehow or something. Well, it's not like a triplet study where you get one poor, one middle class, and one rich, like triplet. This is just different people, right, in the different classes. So what test is it? It is a one-way between subjects, ANOVA. Number two, a researcher wants or collects information on the color of men and women's vehicles to see if men and women differ in car color preference. All right. So what are we doing here? We've got men and women. That's a variable, is sex, right? And we got their vehicle colors. So what color their car is. So we've got one variable that's nominal. That is sex. It's got two levels. We have another variable, car color. Well, that's nominal, right? It's got to be. It's blue or white or red or black, right? That's going to be their car colors. So we have two nominal variables. And what are we comparing here? Well, we're comparing counts of men and women who like each color of car. What test is this? It is the chi-square test of independence. How about a researcher examines typing speed of students before and after a typing class? Okay, remember I told you all pre-post designs are within design, so we got a within design here, okay? Same people before and after. So, oh, I went too fast. But anyway, we're comparing typing speed, that's probably interval or ratio, right? And two groups within design, that is a paired samples t-test. Okay, long one. A researcher asks each participant to rate the quality of 3 cookies. The 3 cookies vary in batter. They could be sugar, peanut butter, or oatmeal. Each participant rates each type of cookie on 5 different Likert measures of quality, which are summed to create an interval quality score. All right, DV is quality score, right? And it's the average across a couple of Likert 1 to 5, how flavorful it was, etc. Right? So that's our DV. What's our IV? Well, it's the batter of the cookie, right? And there's 3 groups. There's sugar, peanut butter, and oatmeal. So we got an IV with 3 levels. What type of design we have? Is it different people tasting separately each of these 3 types, or is it the same people? Well, they're each tasting each of the 3 types of batter. It's a within groups design. Specifically, it's a repeated measures design. So this is what? A one-way repeated measures ANOVA, right? That would be the one to use for this. How about a researcher compares politically conservative to politically liberal students on their attitudes towards the occupation of Iran under 10 different scenarios using a Likert scale, which are summed across the 10 scenarios to create an interval attitude measure. All right, so our DV is this interval attitude measure. We've got 10 scenarios. That's actually just noise in here. They're summing across the 10, but what's the IV? Well, the IV is whether they're politically liberal or politically conservative, right? So the IV is their political stance. And there's 2 groups. You're either politically liberal, politically conservative. Same people or different people in those groups. They didn't say they're matched or like siblings, so it's different people. So what test is this? Boom, it's an independent samples t-test. All right, I hope this is as fun for you as me. Number 6. A researcher examines whether one flavor of ice cream is preferred to others by counting the number of customers who purchase each flavor. So we got counts, first of all, hint, of what's the variable here? Customers, they're just counting customers, but the variable is what flavor of ice cream they like, right, or buy. So that's a nominal variable, right? Strawberry, chocolate, vanilla, etc. And it just counts who buy each flavor. So we have one nominal variable, counts of things. What's the test? Well, the test is the chi-square goodness of fit test. A doctoral student wants to know whether a sample of hypochondriacs are more anxious on average compared to the norm average in the test manual. This one's a little weird, right? So first of all, hypochondriac is a constant. Everyone in the study, well, and so is doctoral student. Oh no, sorry, there's only one guy. So hypochondriac is a constant, so that's not a variable. It's one sample of hypochondriacs, and he's getting their average, anxiety score. So the outcome is anxiety, of the DV. It is interval or ratio, one sample, and we want to know if they differ from some hypothesized population mean. That is, for in the back of these test manuals, they'll say what's the typical score for someone of a given age and sex. And that's basically what they're doing. They want to know if hypochondriacs are more anxious on average compared to expected for their age and sex. And so this is one sample IV that is interval or ratio. You've got a one sample t-test. Finally, the trick one. So there's only one that we haven't talked about. There's your hint. So a company is interested in knowing whether there is a linear relationship between income levels in dollars and the number of times a customer uses their services annually. I tell you it's tricky. So what do we have here? Linear relationship is your hint. Like what do we use that to look at linear relationships between two variables? Specifically, income in dollars is a ratio, so it's interval/ratio. And number of times you use a service annually is also ratio, so interval or ratio. To look at whether two interval or ratio variables are linearly related, that is, give you a hint, you did it, correlation. So again, not in the matrix, that's why it's tricky. So there is an exercise this week called the Inferential Statistics Review Exercise. It is one of your assignments, and your job is in the box where it says statistic. Tell me what is the correct inferential statistic to use based on the matrix of inferential statistics. So, for example, a political scientist wishes to determine whether males and females differ with respect to their attitudes towards defense spending by the federal government. Randomly assigns equal numbers of males and females after being informed, or randomly select, sorry. After being informed about the current budget for defense spending, each person is asked to estimate to the nearest $1 billion an appropriate level of defense spending. So the DV here is how much they think we should spend on defense. So that's interval or ratio. What are the groups? Well, there's males and females. They are the levels of sex. So we've got two groups, different people in those groups. So it's between groups design. We've got an interval or ratio DV. This is an independent T. Another political scientist wishes to determine whether males and females differ with respect to their attitudes toward defense spending by the government. All right, so same damn study. She randomly selects equal numbers of males and females and asks each person if he or she thought the current level of defense spending should be increased or decreased, remain the same, or increased. What's going on here? So what's the outcome? We've got males and females. That's a nominal variable. We've got another variable, it's actually ordinal, right? So whether it should be decreased, remain the same, or increased. And we want to know if the distribution of males and females differs across, whether it should be decreased, remain the same, or increased. And we're probably comparing counts. What test is this? It's the Mann-Whitney U-test. All right, so if you look above independent t-test in the matrix, you'll see if you've got an ordinal DV, and you got two groups, and they are independent design or between groups design. You've got Mann-Whitney U is the appropriate test to use. So it's the backup weed whacker equivalent of independent T. To determine whether speed reading influences reading comprehension, a researcher obtains 2 reading comprehension scores for each student in a group of high school students, one before and one after training in speed reading. Okay. What's this? Well, let's see. You got 2 scores for each student. They're all high school students. That's not a variable. It's all reading comprehension. That's not a variable. So the DV is what? Well, the DV is time. It's before and after this speed reading course, right? Everyone's got a score before and after. The IV is time. Good Lord, before and after. And so what's the DV? Well, the DV is the reading comprehension scores, and it's the same people in the groups. So what test is this? 2 groups. IV, that's interval or ratio, and within design, paired samples T. So let's say that you did that study, so we're doing number 4. You looked at the reading comprehension scores, and you saw that they're really violated one of the assumptions that's required to do a paired T. What's the backup test? Look above it in the matrix. What's the backup for paired samples T test? The one right above it in the ordinal row is Wilcoxon matched Pearson rank t-test. Another research investigator criticizes the design of the previous study, saying that larger numbers of high school students should have been randomly assigned to either the special training condition or a non-treatment condition tested just once at the end of the study. Oh gosh, what are we going to do here? So what do we have? We have two groups, special training or no training, right? So the IB is treatment condition, and they're just tested once at the end of the study. So you've just got people post-tested only, different people in the groups. What is this design now? Well, we changed the design to a between, right? And we just have one outcome measure. It's just their score one time on reading comprehension. We have an independent samples t-test. Finally, an educator wishes to determine whether chance can reasonably account for the fact that 40 of the top 100 students come from the northern district rather than the eastern, southern, or western districts of a large metropolitan school district. Oh boy, what is this one? So we got 100 students. So we're categorizing them whether they come from the northern, eastern, southern, or western part of a school district. So we got counts of the top 100 that fall within 4 categories of a nominal variable. One nominal variable counts. What is it? Is your chi-square goodness of fit test. So give it a shot. Knowing which inferential statistic to choose is, again, one of those top 5 things that I got to make sure you know by the time you get out of this course. So give it a shot, and I will post the key, of course, at some point during the week. And let me know if there's ones that give you particular problems in the discussion and comments, and I will follow up.